You're listening to Let's Talk Creation with Todd Wood and Paul Garner, the creation show where we learn, grow, and worship.
All right, hello and welcome back to another episode of Let's Talk Creation with Todd and Paul. I am Todd Wood.
And I'm Paul Garner.
And Paul, we got a really special episode here for you this time. I'll give you a hint what it's about. Got to be prepared with my proper gear here. And of course, everybody who's clicking on this already knows we're doing an Eclipse episode. So, and it's the American eclipse again. We had one in 2017. Here it comes again. A total eclipse running across from basically Texas to Cleveland, I think. There's quite a big swath of heavily populated U.S. that it's going to be visible from, and we thought we needed to have a good episode dedicated to the eclipse. So, before we get started, though, I want to remind all of our audience members, if you would be so kind to leave a like, leave a review if you're on a platform other than YouTube. Share this episode with your friends. We're going to try to cover a lot of practical information about viewing the eclipse as well. So this will be very helpful for anybody who's interested in seeing one of the most spectacular shows in creation, I think. So thank you very much for your support. Visit us at letstalkcreation.org to find out how you can also support the work that we do financially. And we appreciate everyone who makes contributions to make sure that this podcast continues. All right. Well, enough jabbering. How about we get to the eclipsing? So we have a very special guest with us today. His name is Ron Samec. Hello, Ron. Welcome.
Hello, Todd. How are you doing?
Very good. All right. So Ron is an emeritus professor from Bob Jones University. He is an astronomer. So we thought it was very important to have an actual astronomer and not just, me and Paul talking about stuff. And so we are very grateful to have him here. He is also on the board of directors of the Creation Research Society. So we appreciate his service there. And we're members, right? You're a member, Paul.
Yeah, absolutely.
And I just got some mail from them recently about their new director of their Van Andel Center. So my membership must still be good. Sometimes I have a lot of subscriptions and memberships, and it's hard to keep track of exactly which one is renewing and which one have I done. Anyway, I try to keep it current. So, Ron, thank you so much for being here. We really appreciate this. And how about we just start off with, what is it that we're about to see? What is going on in the solar system that is producing this extraordinary show?
Okay, it is a rare event. I mentioned that we don't have another one until 1945 across the U.S. So it's very important, I think, that people go out and see this one. It does have a big path, and the path is the path of the shadow of the moon as it comes to a cone as it's raised from the light from the sun, and that the point of the cone moves across the U.S. And it's wide enough so that we get a 4-minute total eclipse. However, the whole eclipse from the time the moon touches one edge of the sun actually is covering one edge of the sun to the other edge is about 2 hours and 30 minutes. But and most of the U.S. will be able to see at least a partial eclipse, but the narrow point where the point of the sun's of the moon's shadow crosses the planet is not going to be very wide, maybe 50 miles maximum, and so you need to be in the area where you can see the eclipse. And the major part of the eclipse is the total eclipse. And so again, it's basically what happens is the moon's orbit makes a big circle, close to a circle, and the sun's the Earth's orbit around that. They cross each other at just 2 points, of course, and these are called nodes. And for a lunar eclipse or solar eclipse, both objects must be at a node, and at that point you either get a lunar eclipse or solar eclipse. The lunar eclipse is when the moon passes through the through the Earth's shadow. Actually, the sun's producing a shadow, but through the Earth's shadow. And the solar eclipse is when the shadow from the moon touches the Earth's surface. And so it's sun, moon, Earth situation, and they have to be at a node. And this node slowly shifts around in position with about an 18.6 year cycle. It precesses around, and that makes it so the eclipses are very rare, and they don't happen every time we have a totally a full moon or whatever. But it does happen during a full moon, but only at these rare times. And so it is a major thing. It's the last major total eclipse within a lifetime, or half a lifetime anyway. Yeah. And so I'd say this is very, very important. The key thing about the eclipse is that you only get to see this on the Earth. The other planets have minor partial eclipses when their moons pass in front of the sun, and it turns out that the moon is 1/400th the size of the sun, but the sun is 400 times further away. So the moon's appearance in the sky appears to be the same apparent size, same angular size as the sun. And so when they cross paths, we can have a perfect total eclipse. If the orbits are again, the orbits are slightly non-circular, so but if everything's just right, you can have a total eclipse. And it's just amazing, because what happens at a total eclipse is that the corona, the atmosphere of the sun, suddenly appears, and the chromosphere, which is a very thin atmosphere of the sun, appears for a moment. And at that moment, we can actually see craters on the edge of the moon, the light coming through those valleys in the craters, and we call that Bailey's beads. And so when we have this perfect alignment, we see these amazing things. And of course, they always tell you not to get close to street lights, because the street lights detect the light being dark in the area, and they'll come on. And so you don't want to be near a street light. But that's once you avoid that, and you're in an open area, and the clouds are favorable, and at least they break up or they're thin, you'll see an amazing sight. And I think it's just going to be a wondrous thing that God has done. As I said, on other planets, you get these little partial eclipses. They showed recently on the internet Phobos eclipsing the sun, and it was just a small rock going across the middle of the sun instead of what you see on the Earth. And that was, of course, seen by the robot on the surface, the robots that are wheeling across the surface. Mm-hmm. But anyway, so it's just an amazing thing that God has done, that we can see this event. Also, during that event, people, astronomers and scientists, have taken spectroscopes across the world to see these events. And so at that flash point, at that point where you have the beginning of the eclipse, that total eclipse where these two objects cover each other exactly, there's what's called a flash spectrum. And this flash spectrum is of the thin chromosphere that's around the sun, very, very thin compared to the diameter of the sun, and only appears for a moment. And what happened in 1886 was that the helium line showed up, and actually helium was discovered at that moment.
Oh.
And so God has done this so we can actually know about helium. Now, of course, helium is well understood today, but it would never have been seen spectroscopically, and which gives you all the details about this element. Of course, it's the second element on the periodic chart, and so it's just another amazing thing that happened.
That is amazing. How many eclipses have you witnessed yourself? Can you remember?
I've seen 4 eclipses. One in Greenville, another one at Clemson, and partial eclipses. I saw a partial eclipse a few months ago.
Yeah.
But anyway, from Greenville, but yeah, and it's what is amazing. I was at the Greenville eclipse, which was a few years ago. I was sitting at an 8-inch celestron, actually Meade telescope, and watching the whole thing.
Wow!
And it was just amazing.
I bet.
It was just, now you can see you had your eclipse glasses on, and but you can actually take them off during the totality.
Right.
During those 4 minutes, that small stretch when the moon is completely covering up the sun, and that's when the corona, this amazing, fantastically hot, thin atmosphere around the sun appears, and that's an amazing thing. Yeah. Another thing is the Bailey's beads, which I mentioned, and you never can tell where the light's going to shine through because the moon does wobble a little bit, and you never can tell which craters it's going to show through. In the valleys, you'll see these little points of light around, like a necklace, like a pearl necklace, around the sun. And these events are only seen during totality, and so totality is something that is just an amazing thing.
Wow!
And so it's just wondrous. It is amazing, and everybody needs to see it.
I agree.
One time at least.
I agree. Most of my life I didn't really pay too much attention to eclipses because I'm a biologist and I thought that's an astronomy thing. It's not for me. And then in 2017, there's a total eclipse that came right over my house. So it was like the Lord is saying, you're going to watch this one, whether you want to see it or not. And I was totally hooked, absolutely converted. I think everybody everywhere, no matter what, you guys should go see an eclipse. It is the most amazing thing I think I've ever seen. It's like a big giant hole in the sky where the sun should be. It's crazy. Paul, have you had the privilege over there?
Well, I did. Back in 99, we had a total solar eclipse here in Britain. Now, I wasn't in the zone of totality. I was in Cambridge at the time, but it was about 90 to 95% total. And I remember a number of things about it. I remember there being a very strange change in the quality of the light.
Yeah.
I remember a kind of sudden drop in temperature and the wind, and a kind of eerie silence that sort of descended for a while. It was a very strange event.
Yeah.
And actually, as it happened, I was quite glad that I hadn't travelled down to the southwest to the zone of totality, because down there they had rain and cloud, and I think many people kind of missed it. So I think I probably got the better part of the deal, staying where I was in Cambridge.
Yeah, I remember in 2017 when we had the eclipse here, That's exactly what happened. It got dark, as you said, Ron. The street lights came on, and the cicadas started singing. So they knew it was dark, and yet it wasn't that dark. I mean, it was definitely darker, but it wasn't like dark because there's light, from the sun is stupendously bright. I mean, astonishingly bright. And as soon as totality was over, it was back to being blinding, and you have to put your eclipse glasses back on. But it was definitely dark enough that the lights came on, and it was like dusk, and it was very strange. The other thing I remember about 2017, and we'll talk about this here in a bit. We had our eclipse party down at our office, which is, I don't know, 2 or 3 miles from my house. And it's all pretty much back roads to get there. So I don't have to go out on any major highways to get from my office to my home. But I could see absolute parking lot traffic out on the highway in front of our offices, and thought, wow, those people are going to be there a while. And they had all come up from Chattanooga and surrounding cities to get into the line of totality, which was going right overhead. So that was pretty amazing. So, but yeah, that's a thing to think about as you think about the planning for the 24 this coming eclipse. Now, Ron, I wanted to come back to a theme that you'd brought up there. Now, you mentioned before I do that, you did mention the eclipse on Mars with Phobos. Just a little rock going across the surface of the sun. I remember we watched a transit of Mercury here a couple years back, where Mercury, the planet Mercury, crossed in between us and the sun, and it was exactly that. You got out your eclipse glasses and you put them on, and suddenly you could see, oh, there's a little dot, little speck there in the middle of the sun. But you also mentioned this. Yeah. You mentioned this idea that God has. I mean, this is God's show. I mean, to me, that's what was so appealing about the eclipse. This is just God's most amazing show that I had ever seen in all of creation. And you mentioned that. I mean, the moon is 400 times smaller than the sun, and the sun is 400 times farther away, so that they end up being exactly the same size in the sky. And then when there's an eclipse, we get this complete and utter eclipsing of the entire disk of the sun, so that you can actually see the chromosphere, the atmosphere. Now, I've heard that before. I've heard people talk about how that's I've heard creationists and other design advocates argue that this is part of. I don't know that it's part of it, but they'll often mention it in context with the anthropic principle, the idea that the universe is specially designed for human life, which I think is a very interesting thing, and we're going to have to talk about that sometime. But it seems to me that it's kind of a different caliber, because I don't think having eclipses is something that we need to live, but it certainly does allow us to know about our solar system. So maybe we could elaborate on that a little bit. Did God design this world so that we could understand it? And what does that mean? What is the significance of that?
I think that God is as a scientist, of course, he's the one who created everything, and he wants the people on the earth to study his creation. He wants them to know about it. He wants them to know what he has done. And if you just look at the development of astronomy, what they found out recently, black holes and all kinds of interesting, exciting things. I think that at least, even though many scientists are non-believers, believe that things just happen this way, and we're just very lucky. I think science has advanced, and that God is pleased with the science, and He would rather that all the scientists believe in Him and honor and bring glory to Him for what He's done.
Sure.
And it is amazing that we live in a place that we can see such a sight. And we can, as I said, it does, as you said, it doesn't, it just gives more quality to our life. And God is just showing off his amazing power and what he has done. And he has placed, as it says in Genesis 1:17, he placed the sun and moon in the heavens and did them a particular way. And we can tell from the solar eclipses what that he did that. He is the creator. He is the one who set this fantastic event, this show up for us to see. And we can honor and glorify him for doing that. Yeah. And we can also think about his death on the cross and how he paid for our sins so we can have eternal life and a home in heaven if we believe in him, trust in him, and we'll be with him forever. Right. And see these things forever. Now, in the Bible says the sun and the moon are both eternal, which means these events will take place forever, and we'll probably have some really super seats to see these events in the future. And I know there's going to be a new heaven and a new earth. We'll see what happens there.
Right.
But we'll have to see how that all develops. But I'm just excited that I am an astronomer. I am a professional astronomer, and I still do research and go to telescopes and observe. We have a run coming up in a few days here, and so I can witness these things and see these things. When I went to Clemson for my degree, what I remember is that I was a Christian before I went to Clemson, and so when they talked about these things, I could just sit in my seat and say, "This is amazing. This is wonderful," and I could offer praise to my God for what He's done in my classes. And as I said, many of them, we do have a group of astronomers at the American Astronomical Society meeting that meet, and we have a meeting every time, and talk and think about the ways that we can tell others on our campus. We can spread the word of the gospel to our students, even in this tight atmosphere where people are losing their positions and so forth. And but it's still, the thought is still very strong among Christian astronomers, and this is just one of the amazing events that we see. Yeah, and we have to just bring glory to His name for what He has done, and be thankful for His creation.
Ron, you mentioned earlier about the way in which helium had been discovered, and that this sort of helped us to sort of unlock the nature of the sun and its composition and the nature of the stars. What was the significance of that? And were there some other things? I think I read somewhere that because of eclipses, we've been able to test general relativity theory as well. I just wonder if you could sort of say something about those things.
Right. General relativity, of course, is really a theory of gravity, and it's very important. And because of our observations of the sun and the bending of the light as it comes from the sun, we've been able to prove a lot of Einstein's theory. The black hole event also was another important thing, and it seems like every time that there is a major step forward when we see these events. Now, another thing is that in the heavens, there is dark matter and matter that we can't see, but it causes the light from the stars to bend around and so we can tell that this material is there because of that. And this bending, of course, is a general relativistic effect where the light is actually being influenced and pulled by gravity. So these are, as I said, they're very important things. And the helium also was very important. Here's the second element on the periodic chart that we didn't even know existed. And I'm sure people wondered, where is this element? It's got to be there. And it was seen during these flash spectrums of the total eclipses when the chromosphere just appeared for a moment because of it being just exactly, the moon just being exactly the right size to cover up the light from the sun, to let this light from around the edge from the chromosphere to appear. And so, as I said, this is a setup. God has set these things up for us to be able to understand His creation. And there are many other things coming in the future, I am sure, that scientists will discover. And at least I can offer glory to God for what He has done. And one day I will be with Him and be able to see Him face to face. And to also, I don't know what astronomers are going to do, what Christian astronomers are going to do, but I'm ready, and I'm excited about that.
Yeah,
absolutely.
Yeah, that's great.
But
So
yeah,
I'm reminded of Psalm 19.
These are very good things. Go ahead.
Yeah, I'm reminded of Psalm 19. The heavens declare the glory of God, and this is one of the most. I'm going to keep beating this dead horse, but this is the most extraordinary show I think I've seen in all of creation. I've seen a lot of really cool things out there that God has made, and this was
Right.
this beats it all. And you're right. It's such a rare thing.
Right. So I was thinking, on the lunar eclipse now, of course, Aristotle saw that the Earth was round because of the shadow on the moon as the moon passes through the eclipse, through the shadow of the Earth. And there are an awful lot of things. So we know that despite whatever they say, we're flat earthers or whatever, but we're not, of course.
Right.
And that the Earth is round, and there are a lot of other important things that we can see. Because of our aspects. So we've found out that the way that we understand the solar system is correct, and so there might be some place in the heavens. Heaven knows there are so many planets and so many stars out there where there is another eclipse, but I doubt it. It has to be just perfect.
It's a pretty
We're at
specific setup.
At that perfect place.
Yeah.
Yeah. I find it amazing that the sun's gravity can distort the light of stars that are kind of close to the sun in the sky to the extent that you can measure that gravitational bending and test Einstein's theory of general relativity that way. I just find that astonishing. I mean, it just is mind-blowing, I think.
Right. During eclipses, of course, the stars do appear, and that's another thing that happens during eclipses. People will measure, astronomers will measure the position of stars close to the sun, and they actually change arc second or so, and you can actually it's very small, but it is easily, with our instruments, it's easily found. And that does show us that gravity does affect. It also affects time, and so Christian astronomers have used that to show how everything would fit together into a young Earth model, as the Bible says, that it can slow down time too. And so all these events are very important, and they come because of GR, because of general relativity, because of that great job that Einstein did, and many people have added to that in the intervening years, and we have and people are trying to tweak it and get it to be exact, and even more exact, to many decimal places. That's one thing about quantum mechanics and GR, is that they're very accurate to many decimal places. And we're not just talking about something that is guesswork. It isn't guesswork.
Yeah, right. Yeah. Yeah. Fortunately, I do hear people trying to write off science as guesswork. It's quite a bit more than guesswork.
That's right.
Even if we have disagreements on some issues, it's still way more than guesswork.
Right. And it's interpretation. And that's where the problems come in. We interpret things by eliminating God out of the formula. And we basically, a lot of scientists and so forth. By the way, there are a lot of Christian astronomers, and a lot of astronomers do admit that there is a God. And but as I said, there are. I don't know if the biologists have more atheists or not, but
I think they do.
I'm not going to say that, because biology is also a very amazing area, and there's all complicated things that God has done in the biological microscopic realm, and it just doesn't happen. Things just don't happen by accident.
Yeah.
And,
Yep. Well, shall we talk about planning now for eclipses? Now, Ron, I know you have an event planned. Why don't you tell us about that before we get started here? You're going to have an eclipse viewing party, is that right?
right. And this, of course, is on the 8th. And the eclipse there reaches totality at 3:06 in the afternoon. And it lasts a little bit over 2 hours. But the actual total eclipse is only 4 minutes. And actually, 4 minutes is long for an eclipse. The last eclipse I think that I went to, I was only about 2 minutes.
Yeah.
But if you're there just watching it, it seems like a long time.
It does.
Because there's so many things happening, and it's just so amazing. And so those 4 minutes are very, very important, and they're very jam-packed with information. People are getting together just to look at, like you talked about, the sky and the sounds and so forth, and they're trying to tabulate these things to get a better understanding of what happens during a total eclipse. But yeah, so we're going to be in New Palestine, and Indianapolis, which is just a few miles from Indianapolis.
Okay.
And we're going to be there, and we can only take about 500 people because of the parking. It's at church, and it's New Palestine Bible Church, and we are planning in detail to have as much space as we can, and restrooms and everything for that. And I'm going to give a talk about an hour before the eclipse, about the eclipse, and the night before also. And because it's on a Monday, which is very nice. It says to being Sunday this day before. But yeah, I'll be there, and I'd like to invite anybody that has telescopes to come and help us. If you have a full aperture filter, telescopes, you can project an image of the sun on a sheet of paper or cardboard or something, and you can see the eclipse that way. But if you have a full aperture filter, which covers the front of the telescope, and do not use these little filters. They have these little Japanese filters they have that you actually put it in the eyepiece because they'll crack and you lose your eyesight.
Okay.
But a full aperture filter covers the whole, covers the lens or the mirror completely, and that way you're watching the solar eclipse through to a safe mode, and those don't break unless you throw something at them or whatever.
Right. Or scratch them. Yeah. Yeah. So people are invited. You've got room for 500. Now, I assume you've invited a lot of people yourself, but our audience, if there's room, you'd take them, right? So.
Right. And we have facilities for them, and they can bring their family. And we have eclipse glasses for everybody. And
fantastic.
We bought 500 eclipse glasses for everybody.
Great.
And so everybody can watch, even if they don't have a scope to look through.
Great.
They can watch the eclipse. And again, when the total eclipse happens, when the moon covers the sun, you can actually view it with your eyes, and that's when you should actually do that.
Okay.
And you'll have almost 4 minutes. We'll have 4 minutes, but like you said, the moment the eclipse is over, this when the sun peeks out on one side, it gets very bright.
Right.
And you should use your glasses.
So the glasses. Now I've got my glasses here.
Right.
They're super dark. I put them on. I can see nothing. Yeah. I was looking at the sun earlier today as I was getting ready for this, and I can see. I can look at the sun safely.
Sometimes you can see the bigger spots now are bigger than, of course, they get as large as 10 times the size of the Earth, the dark spots. And you can see spots with your eyes sometimes.
Okay. So
depends on how large they are.
So keep your eclipse glasses because they might be useful.
Right. During the partial eclipse, you can watch those spots, and so that's interesting. Now, the reason why there are spots on the sun is that it is a magnetic star. It has a very strong magnetic field, and it has these big spots that actually, these field lines actually they protrude out of the sun's surface and go back in. And so there are 2 spots actually for every sunspot. They're actually come in pairs. They're called bipolar sunspots. And the larger sunspot is the lead spot that actually leads as the sun rotates. And the smaller spot is behind it as it follows. And they get so many spots that many times they're crowded. And and so many times you see an area of spots. You're actually looking at hundreds of spots. Now I observe eclipsing binary stars, and these are solar type stars, and they have huge spots because they're rotating very, very fast. When with the sun, now sun has like a 30-day rotation period, but if you make the sun spin so that it spins around in just a few hours, those spots get very, very strong, and they can cover most of the sun. They would like the stars. They would cover most of the sun. Some people have said that I have said that the sun is young, and the sun is young, but it was made so it's a quiet, slowly rotating object for the safety of us. And God has made them so it's not like the younger stars and younger solar type stars in the universe, because they have fantastic activity. And we would be dead about 3 times a week if the sun was rotating very, very fast and it was as young as the age is. But God has made it so that it has appearance of age, and rotates slowly, and the spots are small compared to these other stars. And the activity when the material blows off the sun, we still are a little bit worried about that. And you can imagine how it'd be with these stars that are rotating very, very fast. We just would not be alive.
Yeah.
if we had a typical sun that's only a few years, like a few thousand years old or whatever, we'd be in trouble.
Right.
So God has put together everything for us.
Yeah.
And so it's just amazing.
That is amazing. So I want to make sure we understand, since we're giving information about the eclipse here and viewing the eclipse, I want to make sure that everybody understands that when we talk about the eclipse glasses, these are for viewing the partial eclipse as it's coming to totality and as it leaves totality. Is that right?
Absolutely.
Okay.
You can take those glasses and look at the sun anytime and look for spots or whatever. But that's exactly right. And that's very important. And, the eye, generally a person would look away if the light got too bright.
Yeah.
And so we have a natural response, which is good.
That's good. That's a good natural response, because you'd go blind staring at it. But it's a pretty exciting thing to see the whole thing from start to finish, I think. Most people are probably thinking the eclipse is just
Right.
is just the part where the entire sun is eclipsed and the corona is the chromosphere is visible. But it's actually, as you say, a 2.5 hour show from the time the moon starts to go across until it finally finishes. Yeah.
That's correct.
And so that's what the eclipse glasses are for. Now, last time we had the eclipse, I heard a lot of weird stuff on social media. I heard that dogs were going to get hypnotized and stare at the sun and go blind and don't let them outside and all sorts of wacky stuff. There's no real danger here. I mean, the only danger, I suppose, is if you're using the eclipse glasses while you're driving or something. This isn't dangerous, right?
It's not dangerous.
Okay.
As long as you're careful and have some common sense about watching the sun, use the glasses, and make sure your telescope is covered with these full aperture filters. Now you can just take if you just want to project the sun at any time, you can just take a shoebox or something and make a small hole, just with a pen in one side, and it'll project an image on the other side of the box.
Right.
And you could do that with the eclipse too, but it's much nicer to have eclipse glasses, and they're so plentiful that you should just have a pair.
Yeah.
So.
and you can get them. We'll have links to that in the show notes, and we'll also have information about your eclipse party in the show notes as well, so that people can find out about that. Let's see. So so it's okay for my cat to be running around outside during the eclipse. It's not gonna, I don't know what, get fried or something.
No, animals probably are smarter about this kind of thing.
I was gonna say, yeah. I would suspect the animals would be better at it than we are. Not prone to staring up at the sun without our glasses. That's the real danger here, is looking at the sun unprotected.
Anytime.
Yeah, yes, right. Because you blind yourself. I also noted the last time we had a partial here in Tennessee, that projection, that pinhole projection, that works with a lot of things. We have a plastic colander. And if you take that plastic colander outside and hold it up, the light that goes through will in fact show you this partial eclipse on the ground. We were projecting it onto the side of our car, and it worked just fine. So you don't necessarily have to create an elaborate pinhole observation thing. You can use makeshift stuff around the house to be able to see all sorts of really cool effects as the eclipse.
Right. And if you'll notice on the walls of your house, as sunlight is coming through, through little apertures, you'll see suns on the wall,
Yeah.
and it's just that they're projected through these little holes in the
Yeah,
fabric and
that's
whatever.
right. Yeah, yeah. It's pretty amazing. You don't really, I don't think I really appreciate it very much because, it's always round and I don't even think about it. And then when the eclipse comes along and I realize, my goodness, this look like little fingernails or little partial moons on my wall instead of
Right,
the normal circles. And then you realize what you're actually seeing. It's pretty impressive.
right.
All right, so let's see. Details about the eclipse itself. It's April the 8th. Now, that is, or 8th April if you're in Europe. I know some Europeans get really bizarre about the way we specify our date, but yes, 8th of April, or April 8th, 2024. It is prime time in the afternoon. Really no reason to miss it. You don't have to get up at a weird hour to see anything. And it is going across most of Mexico. It peaks somewhere around the border, around Texas somewhere, I think. Is that right?
Yeah, I believe so.
Yeah, so the peak would be the longest. Right, yeah. And the peak then. Yes, I think that's right. It's going to pass through Cleveland and then go right on up northern New York, Buffalo area and that sort of stuff. Right on the Canada-US border. So if you're there, yeah, if you live in totality, go outside and look at it. Come on.
Of course.
Don't be curmudgeons about this. I know we had some curmudgeons that I noticed last time. Why are all these people out driving around? It's just an eclipse. It's amazing, and you should see it. Don't be a curmudgeon.
Right.
Yeah.
Okay, so April 8th.
And you have a special spot. It's called the Earth to view it. So,
Yeah, exactly.
yeah. Now a lunar eclipse you can see all over you don't have this narrow area to see it. You can see it all over the Earth on one side, of course.
Oh, right. Yeah, that's right.
A lunar eclipse is different. And you really need a total lunar eclipse to get to have a decent viewing of that. There is a penumbral eclipse where there's the partial shadow, and that is not very good. But a lunar eclipse is also a very good thing to see. Another thing that's fun to see is a meteor shower. When it's a very good one. There is one about close to Christmas time that happens, and you can go. And that you do have to go out early in the morning, like 3:00. And if there's no moon in the sky, that's better. No full moon, especially. And so there are some events that you can see with your naked eye that are just
yeah. This is astonishing. Yeah, so 2024, April 8th, it's a Monday. Take the time. I'm encouraging everyone listening, watching, you should take the opportunity to go and see this if you need to take a day off or take an afternoon off. My wife and I are going to be traveling all the way up to Ohio to view it because we are full solar eclipse junkies now, having seen the 2017 version. So we're not going to miss this. And
pray for the clear weather. Just pray that
yes, we have to pray. Everyone pray earnestly. All you Christians watching and listening, pray earnestly for a good cloudless day for everybody, so we can enjoy this astonishing show.
And we're going to miss the fun here, Todd. You're going to be enjoying this, but we're not going to see it here in Britain.
Right.
You were telling me before we recorded this when the next one is due in Britain, and it's
I have no idea
for some time. I think did you say it was 2040?
Well,
or something
I have a
like
map.
That?
I found a map online that has eclipses up through 2040. It's a real nice map. We'll probably link to a map like this in the show notes so that folks can identify where in their region is going to be the next big solar eclipse. Now, the next total solar eclipse for Europe is 12 August 2026. And that will cover the westernmost parts of Iceland. And then it's going to swing down and go right across all of northern Spain.
Okay.
So it will miss the British Isles completely. Sorry about that. But if you want to pop down to northern Spain for the weekend or whatever that is, yeah, do it. And then after that, so that's 26. And then after that, there is another one in 2 August 2027. And that one is not quite in Europe, but it will run across, totality covers pretty much the entire north shore of Africa. And it will, in fact, cover some British territory because it's going to go right across Gibraltar.
Okay.
and the southern tip of Spain there. And then across, basically Tunisia and Algeria and Morocco. And then it's going to run all the way across Egypt and then down across Yemen and Saudi Arabia and Libya as well. So for those of you in Europe, our European audience members and fans, there are two coming up pretty quick that will then be visible for you guys, at least accessible to you guys, not too far to travel to see it. In the U.S., sadly, the next one is, when did you say, Ron, 2045?
That's right.
Yeah, 2045. So I will be old. Will we still be podcasting, Paul? I don't know.
Who knows?
Who knows? We'll have our hearing aids and bifocals and all that good stuff. And what did you say there?
2045 goes from top of California down through Florida.
Oh wow!
And that's how that goes.
Yeah, that's going to be another spectacular show.
The very tip of Texas, mostly Arkansas looks like a very good place to be.
Yeah, there you go. So you Arkansas people would definitely want to see that in 2045. And if you're a young person listening, put it on your calendar now. I'm assuming Google's going to last 20 years. I don't know. But put it on your calendar now and remember that that's coming up because you're going to want to see, if you see this one, you're going to want to see another one.
Yeah. And there are eclipse chasers who kind of travel around the world, to see these things, aren't there?
Yeah.
Amateur astronomers and, who are real fans of eclipses and make their travel plans to go see the next one.
Yeah, my friend Danny Faulkner at Answers in Genesis, he is one of them.
Yeah.
But he's also a real astronomer.
Yeah.
All right, so I just noticed here, looking at the map here, you Australians are getting an abundance of God's blessings. It looks like spaghetti strewn across Australia. So Australians are going to have a total eclipse running across Australia in 2028, and then again in 2030, and again in 37, and again in 38. Oh yes, and 3 of those are going to go across New Zealand too. So if you're in New Zealand, yeah, you're going to see it in 37, 38, and 28. So wow, God must really like Australia, I guess. He's really showing them, or maybe they really need a display of God's power down there. I don't know.
It's to make up for all the spiders and all the things that want to eat you and poison
right.
you and and inject venom into you.
Yeah, sorry about all the death creatures down there. Yeah. And then if you're really brave, oh no, that's already happened. Never mind. Oh yeah, 2039. There's one going across Antarctica. So if you're a really crazy eclipse chaser, You better book your Antarctic cruise now so you can watch the eclipse during that eclipse. Well, okay, so I already mentioned the traffic, and I suppose we should say it again. Beware. My suggestion would be, don't just drive away as soon as totality's over with. Give yourself an hour or two after it's all done.
Afterwards.
Yeah, let the traffic sort of empty out. Maybe plan your party near a restaurant so you can go out for an early dinner or whatever, or a late lunch, however you want to do it. Just be real casual about that, because traffic is going to be crazy. Where I'm going to be, I know we're going to have to travel about maybe 10 miles to get into the totality. So that's going to be an interesting thing. I think it'll be pretty easy in the morning, because if you go early enough, traffic will be fine. But
right.
Afterwards, it'll be crazy.
Right.
And a lot of us rural people are not used to these kinds of traffic jams, so it's especially stressful for me.
That's exactly what happens. People have a tendency to leave the moment the totality is over.
Yep. And they're missing half the show.
Right.
There's the whole back half of the eclipse to watch still. So if you're going to go to an eclipse party, if you're going to travel to get into totality, which I highly recommend, definitely be aware of that. Stay to watch the whole thing. Finish the eclipse with your eclipse glasses and your filters. And for photography, if all you've got is your cell phone, you certainly can put those filters right over your camera and take a picture. It's not going to be a great picture, of course, because, the sun is very small and your camera's maybe not so good at zooming, but at least you'll get something. If you have an actual camera, you can buy filters that are bigger than this. They're like, you can get them. I bought a couple on Amazon already. So if you hurry up, you can probably still get some for this eclipse, and you can just basically put it over the front of your camera lens, get your best zoom lens that you have, put it over the front of that lens, and then zoom in on the sun, and it's going to be quite impressive. And even if you think you're not going to get a very good shot of it, I found with the kind of resolution that I have on my cameras, the cameras that we use like for podcasting and stuff were just adequate enough with their zoom and so forth. If you have a DSLR, it should be perfectly fine. And just make sure you get that filter. And then, of course, when it's total, doesn't matter because the moon's covered the sun. And so zoom right in on that totality and get that picture. And it looks pretty spectacular. Anything else we should mention, Ron? Can you think of anything else?
As you were talking there, I was thinking you can buy that eclipse material in sheets, and so you can use that to cover anything you want.
Yeah, that's right. Yeah, and that's a great opportunity. And sure, take pictures of your little projections if you've got your colander out and you're projecting little half moons or quarter moons on the ground where the moon is moving across the sun. Take pictures of that. There's just fun things to do. If you have a camera that can do time lapse, I did this in 2017. I set up a time lapse camera on a little tripod and just went away, and so you could watch the whole thing from start to finish as the shadow went by, and it went from super bright to super dark and then super bright again. Yeah, so there's lots of possibilities, lots of fun things that you can do to record and remember. But there's nothing going to substitute for actually seeing it in person.
And don't buy eclipse glasses from somebody who charges you $100 or something.
Yes.
They're normally worth about 50 cents.
That's right. Yeah. I remember the last time our local gas stations had them for $10, which is quite a markup. And of course, people were paying it because they were desperate. So plan ahead and don't necessarily, break the bank trying to buy your eclipse glasses. They're super cheap and easily obtained. And Paul, start thinking about 2026.
Yeah.
Time to go down to Spain, book your flight and your hotel, and maybe we should both go there and do a live episode. That would be kind of a hoot, wouldn't it?
What a great idea.
Yeah. With that much lead time, we might actually be able to do it. All right. Well, I see we're actually out of time. Thank you so much, Ron, for being with us.
Well, you're welcome. I'm glad to have been with you and talk with you, and please go to it.
Yes.
Wherever you go.
Please go and see it. It is a grand show, and we are so grateful to the Lord for putting us on such a perfectly positioned planet with such a perfectly positioned moon and the perfect sun just for us. And the least we can do is get out of our houses and go and appreciate the beauty of the eclipse and pray for no clouds.
Right.
All right. Well, that's about it. That's about all we have time for. Paul, I don't know what we have coming up, but I do want to remind our listeners, if you've made it through the entire episode, do consider leaving us a like and a review, positive review. Share this episode with your friends. And if you see some weird, sketchy, dodgy information about, hypnotized dogs in the middle of the eclipse, please do share this episode with those folks. It's not dangerous. Just be very sensible and you'll be fine. So thanks for listening. Thanks for watching. And we will see you in 2 weeks for another episode.
Yeah, we'll see you then.
Thanks for listening to this episode of Let's Talk Creation. For more information, visit us at letstalkcreation.org, where you'll find an archive of past episodes and all our show notes. If you'd like to leave a comment or make a suggestion, you can find us on all the major social media platforms. Let's Talk Creation is brought to you in the U.S. by Core Academy of Science and in the U.K. by Biblical Creation Trust. As a listener-supported ministry, we are grateful for all of your financial support. Find out how you can make a contribution at our website, letstalkcreation.org. Also remember to like, subscribe, and share this episode with your friends. Thanks, and see you next time.